Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0369 indicates an intermittent interruption in the CMP Camshaft Position Sensor B circuit. This particular code is significant as it suggests issues in the timing of the engine's camshaft operation, which can affect vehicle performance. Understanding the role of the CMP sensor B is crucial. It provides essential signals to the engine control module, ECM, to optimize ignition timing and fuel injection based on camshaft position. The component may be located near the cylinder head, along with the associated pulse plate responsible for relaying position information. Therefore, diagnosing this code requires a methodical approach to ensure all potential causes are addressed, from sensor functionality to wiring integrity. In addition to the CMP sensor and pulse plate, poor connections to the ECM can lead to erratic sensor readings, leading to performance issues, emphasizing the importance of thorough examination and diagnostics. The CMP sensor B plays a vital role in the engine's operation by detecting the position of the camshaft and transmitting this information to the engine control module, ECM. This data is crucial for precise control of ignition timing and fuel delivery, ensuring the engine runs efficiently. Typically, the CMP sensor is located on the cylinder head, often near the timing belt area, allowing it to gauge the camshaft's rotation effectively. Additionally, it works in conjunction with the pulse plate B, which facilitates the generation of pulse signals indicating the camshaft's position. If either the sensor or pulse plate experiences damage, it can lead to incorrect timing, potentially causing performance degradation or engine stalling. In diagnosing DTC P0369, checking the physical condition and operational status of these components becomes imperative. Several possible causes can lead to DTC P0369, each of which requires careful investigation. First, a malfunction within the CMP sensor B itself could lead to erroneous readings or failures in communication with the ECM. This could be due to internal faults or wear over time. Next, wiring issues, including frayed or shorted wires, can disrupt the signal integrity, leading to intermittent failures recognized by the system. During diagnostics, it's also essential to check for poor connections at various terminals, including those connected to the CMP sensor and ECM, as loose or corroded terminals can result in inconsistent signals. Furthermore, a damaged pulse plate B may fail to relay accurate camshaft positioning data, causing disruption in the timing necessary for optimal engine performance. Each of these components plays a fundamental role in the proper functioning of the CMP system, making thorough checks critical. The symptoms associated with DTC P0369 can significantly impact vehicle performance and drivability. One common symptom is engine misfires, which may occur because of improper timing dictated by faulty camshaft position data. As a result, you may experience poor acceleration, particularly during rapid acceleration, where precise timing becomes crucial. Additionally, an unstable idle may be observed, leading to fluctuations in engine RPMs while the vehicle is stationary or at low speeds. The presence of the check engine light is almost a given in this scenario, as the ECM identifies discrepancies in sensor readings and triggers a warning. Collectively, these symptoms highlight the need for immediate investigation and resolution, as neglecting them can lead to further complications, such as reduced fuel efficiency and potential engine damage. To initiate the troubleshooting process for DTC P0369, the first step involves ensuring the ignition switch is turned to the on second position without starting the engine. This prepares the vehicle's systems for diagnostic tasks. Once this is done, The next essential action is to use the HDS, Honda Diagnostic System, to clear any existing DTCs from the computer. Following this, start the engine and allow it to idle for approximately 10 seconds to stabilize. Afterward, check the CMP noise data using the HDS. This data reflects the operational status of the CMP sensor signal. If the HDS indicates 0 counts, this suggests that the CMP sensor is not displaying noise interference and may be functioning correctly, guiding you toward the next step in the troubleshooting process. Conversely, if there are counts noted, it indicates a potential issue warranting further checks. In troubleshooting step 2, a thorough test drive of the vehicle is paramount. During this test drive, it is essential to replicate conditions surrounding the recorded freeze data parameters related to engine and vehicle speed. This action aims to determine if the CMP noise metric reflects similar results as before. After the test drive, check the CMP noise again using the HDS. If the readings still show 0 counts, it indicates that the issue has been duplicated, signaling a confirmed fault that needs to be addressed. Should the metrics indicate counts, this can imply an intermittent failure in the system. In such a case, it is advisable to inspect for possible poor connections or loosened terminals associated with CMP sensor B and the ECM. This step is critical for ensuring that any electrical disturbances affecting camshaft position signaling are identified and resolved. The third step in troubleshooting, DTC P0369, focuses on inspecting the connectors and terminals that link to vital components such as CMP sensor B, the ECM, engine ground, and body ground. First, carefully evaluate the physical condition of these connectors to identify any signs of corrosion, debris, or damage that may hinder proper electrical connectivity. Any loose terminals or poor connections can lead to erratic signals, which is crucial for the sensor's functionality. It is essential to ensure that all connections are intact and secure. If not, addressing these issues through cleaning or repair is necessary. Reach out to the ECM or engine ground connections, as a poor ground can profoundly impact sensor readings. These checks are fundamental to isolating the cause contributing to the DTC and ensuring a solid signal path for effective engine management. In the fourth step of troubleshooting, it is necessary to conduct a visual examination of CMP pulse plate B, which requires removing the cylinder head cover. This step is crucial because the pulse plate is responsible for generating the signal that communicates the camshaft's position to the ECM. Carefully inspect the pulse plate for any signs of physical damage, such as cracks, breaks, or warping. If damage is identified during the inspection, it is imperative to replace CMP pulse plate B to restore proper signal functionality. However, if the pulse plate is found intact, the next course of action is to replace CMP sensor B itself, as it may still be sending incorrect signals to the ECM despite the pulse plate being undamaged. This decision-making process is vital, as either component can be responsible for triggering DTC P0369, and thorough checks are necessary for effective rectification. After the necessary repairs and replacements are performed for DTC P0369, it is crucial to verify that all have been conducted successfully. Start by turning the ignition switch to the lock 0 position to ensure a safe working environment. Following this, all previously disconnected connectors must be reconnected to ensure complete and accurate electrical circuit pathways. Next, turn the ignition back to the on position without starting the engine. Then reset the ECM using the HDS. This reset allows the ECM to recalibrate itself following the repairs. After resetting the ECM, conduct the ECM idle learn procedure to inform the system of the baseline idle conditions. Finally, start the engine and allow it to idle for another 10 seconds as a final check. Use the HDS to look for any pending or confirmed DTCs. If DTC P0369 persists, then further investigation into connections and terminals will be necessary, ensuring that no issues were overlooked. To prevent future occurrences of DTC P0369 and ensure the longevity of the engine's performance, establishing a routine for preventive maintenance is essential. Firstly, regularly inspect all connectors associated with the CMP sensor and the ECM. This helps identify any signs of wear, corrosion, or loose connections before they lead to larger problems. Monitoring voltage levels can also be beneficial. Ensure that the readings are consistent and within the manufacturer's specifications to avoid triggering erroneous codes. Additionally, performing periodic checks on the sensor functionality can preemptively catch issues with the CMP sensor B or its corresponding components. Ensuring ground integrity is another critical aspect. The ground connections of both the ECM and engine must be clean and secure to facilitate reliable operation, mitigating fluctuations that can lead to diagnostic trouble codes. Adhering to these preventive measures can significantly reduce the risk of recurrence and maintain optimal vehicle performance. In conclusion, DTC P0369 signifies an intermittent issue within the CMP sensor B circuit that requires serious attention. Understanding the critical role of the CMP sensor in engine timing and efficiency underscores the importance of meticulous verification when troubleshooting. Throughout this guide, we reviewed various potential causes, ranging from sensor malfunctions to wiring issues. Each step in diagnostics emphasized careful inspection and verification of connections, ensuring that all components are functioning correctly. Following repairs, it's essential to implement final verification to ensure the issue is resolved effectively. By adopting preventive maintenance strategies, such as regular inspections and monitoring, the risk of future occurrences can be significantly minimized. Raising awareness and understanding of DTC P0369 assists in effective vehicle management and assures smooth performance. Please like and subscribe to the channel. See you next time.